Bismillahirrahmanirrahim. Assalam O Alikum. Dear student, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus National Book Foundation Physics SSC 2 Unit number 13 Electrostatic. Now we will discuss about SLO base according to FBISC requirement examination. Today we will discuss numerical problems question number 5 to 8 in part 2. Now we will discuss about question number 5 numerical problems given statement of question number 5. 90 joule of work is done to move two coulomb charge between the 2 points having the potential difference. Point at lower potential has electrostatic potential is 13 watt. Find the electropotential of the other point. Now, according to the given statement, first of all write the given data. Work done, that is equal to 90 joule. 90 joule of work done. So work done is equal to W, that is equal to 90 joule. And charge Q is equal to 2 coulomb. So Q is equal to 2 coulomb. Lower potential has electric potential V1 is equal to 13 volt. Now we can find that potential on Vf mean final potential or V2. Now according to the statement we can write the formula work done is equal to charge multiplied by change in potential delta V, or we can also write that W is equal to Q into Vf minus Vi. So according to the formula we can solve the given values. Now we know that work W is equal to Q into Vf minus Vi. This implies that putting the values W is equal to 90 is equal to 2 into Vf minus 13. Here 2 is multiply, it will be divided on other side, then 90 divided by 2 is equal to Vf minus 13. 90 divided by 2 is equal to 45 and 30 move on other side. This implies that Vf electric potential is equal to 45 plus 13. Vf is equal to 58 volt. Now in question number 6 numerical problem, question number 6 given statement is that two capacitors of a capacitance 5 microfarad and 10 microfarad are connected in parallel with the battery of 20 volt. So we can find that number 1 equivalent capacitance of combination, or in B part total charge stored on the combination. In C part charge on each capacitor. Now in D part potential difference across each capacitor. These are required that in the given question. Now first of all write the given data. Capacitance of one capacitor C1 is equal to 5 microfarad. So micro is equal to 10 raised to power minus 6. Then C1 is equal to 5 multiplied by 10 raised to power minus 6 farad. Here this value is 5 multiplied by 10 raised to power minus 6 farad. And capacitance of capacitor C2 is equal to 10 microfarad, that will be equal to 10 multiplied by 10 raised to power minus 6 farad, because 1 micro is equal to 10 raised to power minus 6. So, according to the statement, voltage V is equal to 20-volt battery. So, V is equal to 20 volt. Here, required that in a first condition, equivalent capacitance of a combination. Now, in a B part, total charge stored in a combination. In C part, we can require that the value of charge on each capacitor. And in D part, potential difference of capacitors. Now, solution for first part, for parallel combination, the equivalent capacitance is given that by the formula CE is equal to C1 plus C2, because in a parallel combination, capacitance is CE is equal to C1 plus C2 plus C3 so on Cn. Here two capitans, so CE is equal to C1 plus C2. Now adding both values, CE is equal to 5 plus 10, that will be equal to 15 microfarad. Now we can find B part. We know that Q is equal to CE multiplied by V. The value of CE is 15 microfarad, then 15 multiplied by 10 raised to power minus 6, and battery voltage is 20 volt, so multiply by 20. Then Q is equal to 15 multiplied by 10 raised to power minus 6 multiplied by 20. So Q is equal to 300 multiplied by 10 raised to power minus 6 farad, or charge Q is equal to 300 microfarad. Now in a C part, we know that Q1 is equal to C1V and Q2 is equal to C2V. First of all, we can find that Q1 is equal to C1 multiplied by V. The value of C1 is 5 multiplied by 10 raised to power minus 6 multiplied by 20. So 5 multiplied by 20 is 100 multiplied by 10 raised to power minus 6. So Q1 is equal to 100 microfarad and Q2 is equal to C2V. So similarly, Q2 is equal to C2V is equal to 10 multiplied by 10 raised to power minus 6 multiplied by 20. 10 multiplied by 20, that is equal to 200 multiplied by 10 raised to power minus 6 farad, or also equal to 200 microfarad. Now in a D part, potential difference across each capacitor. So the voltage of the battery is 20 volt and combined in a parallel combination. So V is equal to constant and V is equal to 20 volt. Now we will move the next question. Numerical problems in question number 7. Given statement, two capacitors of capacitance is 3 microfarad and 6 microfarad are connected in series with the 10 volt of battery. Find here first part equivalent capacitance of the combination, and in second part total charge stored on combination, and third part charge on each capacitor, and last part potential difference across each capacitor. Here these capacitance is find in series combination. So, first of all, according to the statement given data, capacitance of first capacitor is C1, that is equal to 3 microfarad. 3 multiplied by 10 raised to power minus 6 farad, and capacitance of other capacitor, that will be equal to C2 is equal to 6 microfarad, that is equal to 6 multiplied by 10 raised to power minus 6 farad, because 1 micro is equal to 10 raised to power minus 6. Now the battery voltage V is equal to 10 volt. Here required that equivalent capacitor CE, and also find the B part total charge in stored, so equal to Q, and in C part charge of each capacitor, that is denoted by the voltage across C1 is equal to V1 and voltage across C2 is equal to V2. Now we can find the first part. In first part, series combination, the equivalent capacitance is equal to 1 upon CE is equal to 1 upon C1 plus 1 upon C2. So 1 upon CE is equal to 1 upon 3 plus 1 upon 6. Taking the LCM, so LCM of 3 and 6 is 6. So 3, 6 divided by 3 is 2. So 1 upon CE is equal to 2 plus 1 divided by 6. 2 plus 1 is equal to 3, then 3 divided by 6. 1 upon CE is equal to 3 upon 6. Here 3 upon 6 is equal to 1 upon 2. Taking reciprocal on both sides, this implies that CE is equal to 2 microfarad. Now we can solve B part. For a series combination, charge of each capacitor is same, then Q is equal to Q1 is equal to Q2. Then we have Q is equal to CE multiplied by V. Now we have Q is equal to 2 multiplied by 10 raised to power minus 6 multiplied by 10. Here 10 multiplied by 2, that is equal to 20. So Q is equal to 20 multiplied by 10 raised to power minus 6. This implies that Q is equal to 20 microcoulomb. Then we solve the C part for a series combination, same charges. Q1 is equal to Q2 is equal to Q, that will be equal to 20 microcoulomb. Now in last part, we can find the voltage across C1 and similarly C2. Here V1 is equal to Q over C1, that is equal to 20 multiplied by 10 raised to power minus 6 divided by 3 multiplied by 10 raised to power minus 6. So that is equal to 6.66 volt. Similarly, we can find the value of V2, that is equal to Q upon C2, that is equal to 20 multiplied by 10 raised to power minus 4 divided by minus 6 divided by 6 multiplied by 10 raised to power minus 6. Here 20 divided by 6 is equal to 3.33 volt. So V1 is equal to 6.66 volt and V2 is equal to 3.33 volt. In next numerical problem 8, if a capacitor stores 10 coulomb charge when connected with a battery of 200 volt. How much charge will be stored on it if connected with 40-volt battery? Now, in the given statement, capacitor store charge 1 Q1 is equal to 10 coulomb, and we have voltage V1 is equal to 200 volt. Also, voltage V2 is equal to 40 volt. We can calculate that charge Q is equal to question mark. Then using the formula and find the solution. Here Q1 is equal to C1 V1. Then we can find the value of C. This implies that C is equal to Q1 over V1. So C is equal to 10 divided by 200. Then 10 divided by 200 is equal to 0.05. Now, similarly, we can find the value of Q2. Here, C is a common in both, so C multiplied by V2. So Q2 is equal to C multiplied by V2. This implies that Q2 is equal to 0.05 multiplied by 45. That is equal to 2.25 coulomb. So charge on other capacitor, that is Q2, is equal to 2.25 coulomb. Best of luck. Next and more videos. Subscribe our channel. Best of luck. Allah.